Okay, I'm going to do problem 23 on page 393, which is in section 7.5, estimating a population variance or standard deviation as well. Listed below are the measurements and amount of lead, and by the way, there's 6 observations down there, which I won't read, but you can look in your book and find. Listed below are the amounts of lead in the air. The EPA has established an air quality standard for lead of 1.5. I think that's micrograms per cubic meter. I'm not very good with those, but the measurements shown below were recorded at Building 5 of the World Trade Center site on different days immediately following the destruction caused by the terrorist attacks on September 11, 2001. Use the given values to construct a 95% confidence interval estimate of the standard deviation of the amounts of lead in the air. Okay, so what we want to do first is get the summary stats, since they just gave us observations. I believe N is 6, and I use StatCrunch to find the sample standard deviation. S is 1.9142. And so what we want to do is create a confidence interval. And keep in mind, when you do one of these, it's going to look like this. So we're going to have n minus 1 here, and here. Here, we're going to have the sample variance. This is the sample standard deviation. You want the sample variance. So 1.9142 squared. 1.9142 squared. That. And we're going to divide by the chi-square critical values. Keep in mind, since we want the lower endpoint to be smaller than the upper endpoint, we put the bigger one here and the smaller one here. So I'll show you how this works using the chi-square table. So you can see I've got the StatCrunch a little bit up here, the summary stats, but we minimize that. Okay, so this is the chi-square table. And the way this works is similar to the t-table, but we're going to pick, since it's not a symmetric distribution, since the chi-square is a right skew distribution, we need to pick out the left and right separately, because they're not just going to be one positive and one negative. So we need to get our degrees of freedom. Since we have a sample of size 6, we'll use 5 degrees of freedom. And what we want is the leftmost critical value. This is the area to the right of that. So since we're doing a 95% interval, we want the leftmost endpoint to have 0.975 to the right of it. And we want the rightmost endpoint of this chi-square critical value to have only 0.025. So for a 95% confidence interval, you would use 0.975, 0.025, and go down to your degrees of freedom. So 0.831 and 12.833. These are the two values that we're going to use for a 95% interval with 5 degrees of freedom. For example, if you wanted to do a 90% interval, well, you'd have 5% in each tail if you wanted to have 10 total. So you'd use 0.95 and 0.05. So if you're going to do a 90%, you'd use these two critical values. And 80% would, so this is 80, 90, 95, and etc. You guys can figure out the rest there. But again, 95 is probably the most common. So we're going to use 0.831 and 12.833. And again, did I say it's 12.833 would go here. And again, if you forget, when you divide by a bigger number, you end up with a smaller number. So that's the left endpoint. And over here, it's 0.8. Did I say 31? Yeah. And when you just do the calculations, you get 1.1948 up to 4.6954. And if you wanted to do a confidence interval for the variance, this is a confidence interval for the standard deviation. If you want to do a confidence interval for the variance, you would just not do the square root. A couple other things here. This says, is there anything about this data set suggesting the confidence interval might not be very good? Well, we need to think about our assumptions here. When you do one of these confidence intervals, there's no such thing as the central limit theorem. It doesn't apply. What you have to know is the population's normal. So in a situation like this, what you probably want to do is take a look at some graphs and summary stats. And again, I don't mean to keep switching here, but so if we take a look at some of this stuff in StatCrunch, I've already typed the data set in. The graphics, let's look at a histogram first of variable 1 and create the graph. So if we look at this graph, this is a very right-skewed histogram, and which would suggest that probably the population may not be very normal. If we look at a QQ plot, it kind of tells the same story. The QQ plot, we see this. And it also suggests that there's kind of a linear trend here, and then this, which is an outlier. And if you look at the numbers, we've got a 5.4. And what's probably unique about these numbers is this. These were recorded on consecutive days after the 9/11 attack. We would expect there to be some sort of time series correlation, such that probably those levels, or lead levels, would be the highest immediately after and then kind of fall off. So we're treating this as a simple random sample, which it really isn't. It's kind of a time series type of thing. So I think that's what the book's getting at in their follow-up question. So I hope this helped. Thank you.